So hey guys, so let me set the context for this video. In this video, we are learning about what is JWT. For understanding and learning JWT, you need to understand a couple of things like what is encoding, what is encryption, what is hashing. Then we have symmetric encryption, asymmetric encryption. So they are the type of encryption. What is digital signature and how it works. Then we will understand JWT. Then we have to understand OAuth. So there are some of the things to understand. So let's start with encoding. So what encoding is? So let's understand encoding with the help of example. So let's say we have two computer 1 and computer 2. Computer 1 try to send man a string, that is data, to computer 2, and computer 2 can also send data to computer 1. Now how this data can be sent to computer 2, and computer 2 can understand this man or know this is the data that is being sent. So for that, what we can do, we can somehow convert this man to binary 1010. Let's suppose the man binary is 1010 for this example. Now when we send this data through the network to computer 2, now the problem here is how computer 2 will understand 1010 is man. Now let's say I tell computer 2, hey bro, 1010. So you can think like so you can think like 10 is M, 1 is A, and 0 is N. So you tell computer 2, hey, 10 is M, 1 is A, and 0 is N. For this example, let's say for this example, 10 is M, 1 is A, and 0 is N. Now if the computer 2 have this information, now computer 2 can understand 1010 means man. Now let's see computer 3 will come. Now when computer 3 will come, we try to send this data again to computer 3. Now the problem with computer 3 is same. How this computer 3 will understand 1010 means man. So you can detect the problem here, right? So that is the core problem that encoding solves. Encoding means reversible transmission of data into another format by using publicly known schema. So what do you mean by publicly known schema? That means the schema that you are using should be publicly available. Okay, so let's say how. Let's explore some algorithms for encoding. First algorithm is base 64. Then we have UTF-8 encoding. Then we have URL encoding. So these algorithms used to convert data into another format for transmission using publicly known schema. Now let's suppose we are using base 64 here for sending data 1 to 2. What we will do, we will encode this man with base 64 and send that base 64 to person 2. Now person 2 also know this data is encoded by base 64. Now computer 2 will use base 64 to decode this data and understand this data. Same for person 3. So that's how encoding solves this problem. And one more thing, encoding of a data is reversible. That means if I send man to 1010 and 1010 can be converted into man. So this is reversible. But the problem with encoding is, let's suppose another person somehow get this 1010. Now another person will somehow predict, let's suppose we have only two schema, base 64 and UTF it. Now this person this person or hacker can know the data that I am sending, because we have only two things. He will first try base64, then he will try UTF it, and this person will know what is the data. So encoding is not secure, it is only for transmission purpose. We convert data from one format to another by publicly known format or schema or algo, you can say. So now the problem with encoding is that if we send one, or you can say if we send man to computer 2, now this data can be tampered or can be changed by a hacker. This hacker intercept the request, change this data to man, and then sends back to 2. Now when 2 will decode this data, 2 will understand, oh this is man, but actual data is man. So this is not, you can say, the problem. This is, you can say, the limitation of the encoding. So this problem can be solved by hashing. So what hashing means? Hashing means, let's suppose if we have a data man. Now what we will do, we will use some algorithm to hash this data. Hash means one-way transmission of data, one-way transformation of data into fixed size. For example, we can hash this man to something like anything like 10101010. Okay. Now the man is hashed to 1010, and this length is fixed. Okay. A simple hash function, you can think like, let's suppose I have 24. We can use some modulus operator to hash this, modulus by 2. So this will be 0. This will be 0. Now 10 hash is also 0. So this is a very simple hashing you can say algorithm. In practical life we use much more complicated algorithm, and so this is called collision, and the collision in the real life algorithm is very unlikely, you can say. But collision can be possible. So for hashing, what we will do, we will have man, we hash the data into a hashed text. And one property of hashing is that it is very hard to reverse. That means from 1010 this data I cannot get back to man. Then the question arises, why do we even use this? We can use this, and let's understand one more property. So the hash function, if we put the same data in the hash function, let's suppose this is the hash function, we put the data and this spit out the hash. If we put a, then hash, let's suppose the hash will be 101. If we put again a, the hash will again be 101. That means if we put the same data, the hash will be same. So these are the two very important property of hashing. Now we use hashing in our life, like we want to store, let's suppose, a user password. So what we will do, let's suppose the password is 12345. What we will do, we will hash this password to 1010. This is, let's suppose the hash is this, and we will store this hashed value. We will not store the user password. Now what do we have? We have only hashed value. We don't know the real password. Now how we can compare? Then if a user come and log into our system and put the password, and that request come to our backend, how should we know that the password is correct? We can simply again has the password. Let's suppose a user enter 1 2 3 4 and 6 here, then its hash will be different. And what generally we do, we match the hash. This hash should be equal to this hash, and if this is true, then the password is correct. If this is false, then password is incorrect, because if we put the same data in the hash function, the output hash will be same, right? So you can, yes, so this is called hashing. So what we have understand till now, we have understand encoding, we have understand hashing. Now so now that we have understand the hash, let's get back to our example. Let's suppose person let's take the fresh slate. Person one, or person one, you can say computer one. Computer one try to send a man. Now this data, if we has this data to something else, 101010, and we send this data via network. Now if a hacker somehow know this has data, he will not get anything, because he cannot reverse this data back. It's very hard to reverse, or you can say it's almost mm, impossible, but it can be done by, you can say, brute force approach. But this is very hard to get the original data back from the hash text. Now, and if we encode this data, and then send the data to person 2, now if a hacker will take this data, now he can get the original data back from this encoded text. So this is encoded, this is hashed. Now the problem is how we send this data securely from person 1 to person 2. If we send the hash text, let's suppose person 2 will get the hash text, how he will understand 1010 means man, because he cannot reverse it. So do hacker cannot also reverse this data. For that, for solving this problem, we have encryption. So encryption, we use encryption to securely transfer data. So we have two types of encryption. The first is symmetric, then we have asymmetric encryption. The property of symmetric encryption is that, so first let's take an example. We have person 1 person 2, or computer 1 computer 2. We have man. What we will do, we will encrypt this data, and in encryption we use keys to encrypt the data. Let's suppose my key is anything 5. My 5 is my key, and we need to tell the other party what is the key, because without the key, other party with the without the key, other party, we won't be able to encrypt or decrypt the data. So we need to tell this party, hey bro, key is 5. Now he encrypt this data. Let's suppose the encryption text in the encryption text is known as cipher text. Now we send this text to person 2, and person 2 will get 101010, and it will decrypt this data with 5. Now from 5 he will get man. Now let's suppose if a hacker get this 1010 from this request, the data, can he get the original data back from 1010? No, because he don't have any key, because I only send the key to other party. If a hacker will have the key, then he can get the original data back, but hacker didn't have the key. So we say our connection is now secured. We can send some data securely through encryption. Now let's see We have two type of encryption: symmetric encryption. In symmetric encryption, one key is used, key is one, and in asymmetric encryption we use two keys. Symmetric encryption is very fast because here the key length is relatively small as compared to asymmetric encryption, and it is a bit slow as compared to symmetric encryption. This is generally used for bulk data. This is generally used for small amount of data. Now, now, now that we have understand hashing, encoding, hashing, and encryption, let's compare on the basis of some property or some criteria. Let's first take purpose. The purpose of encoding is to format data. The purpose of hashing is to verify or identify the data. That means, let's suppose if we have 101010, this data should not be tampered in between. So that's why verify or identity means. Then we have hide data. In the encryption, data is hidden because you cannot get the data back if you don't have key. For the reversibility criteria, encoding is reversible, hashing is not reversible, and in encryption, if we have key, then we can reverse data. If you don't have key, we cannot reverse the data back. For the key required criteria, in encoding key is not required, in hashing key is not required, but in encryption key is required. It depends on type of hashing. If we have asymmetric hashing, then two keys required. If we have symmetric hashing, then only one key is required. Then let's compare on the basis of security. Encoding is not secure because you can get the data back without any key, or if you just know the publicly known schema like base 64, UTF-8. Then in hashing, we have some amount of security because a hacker cannot get the original data back with this text, but so the user cannot. User cannot also get the original data back from this text. So some amount of security is there in the hashing. Now, in the encryption, yes, the encryption is very secured. It's secured because we encrypt data with keys, so that's why it's secured. And we have some types of encryption. Now, output size. The output size of encoding is variable. That means this doesn't mean one encoding can be 10, another encoding can be 1010. So this size is variable in the encoding. And in the hashing, the size is fixed. If you pass one, the size, let's suppose the size is 3, it will get the size of 101. If you pass 1000, it will again get you size of something 3-digit size, 01, 001. And in encryption, the size is variable. Again, the size is variable in the encryption. So I think, okay, yes, now I think we have understand encryption, we have understand encoding, we have understand hashing, and we know their properties, algo, how they are used. And for dry run, we will dry run this symmetric and asymmetric encryption. I will create a separate video for this only, symmetric and asymmetric encryption. Then we will move to digital signature. Then we will understand JWT. Then we will understand how OAuth works. Yes. Okay. Thank you guys. If you like the video, please subscribe. Thank you.